This is it, the last video before we actually start putting these functions onto graphs. We've talked about lots of different components of the graphs. We haven't actually graphed the functions. We will do that in the very next video. In this one, I want to really quickly talk about how to find the y-intercepts of rational functions. It's so simple and easy to do. You're really going to like it. So basically, we're going to find these the easy way. We are going to go back to that very starting rational function before we factored, before we simplified, before we did anything. We're going to let x be 0, and then whatever is left over, we're going to simplify. Let me show you what I mean. All right, so in our first example, we had 3x minus 4 over x minus 2. So to find the y-intercept, and let's use green for this, to find the y-intercept, we basically let x be 0. Well, that's 3 times 0 minus 4, which is just negative 4. And in the denominator, we've got x minus, I'm sorry, 0 minus 2, because remember, I'm letting x be 0, and 0 minus 2 is just negative 2. So super easy to find the y-intercept. Let the x's be zeros, and whatever the constant terms are going to be what's left over, and you just reduce those. Negative 4 divided by negative 2 is positive 2. So this function crosses the y-axis at positive 2. I can go ahead and put a dot there. I know that it's going to cross there. And I'll go ahead and say that this function is going to kind of curve down through here when we eventually get to graphing it. And there's also going to be a similar one up here in quadrant 1. We'll get to that in the next video. We do want to make sure that we mention that the y-intercept is 0, comma 2. Awesome. Super easy, right? Let's look at a few more examples just to make sure we got it. Now, you can do this with the factored form. It's just going to be a little bit more work. If you start with the original one and you let x be 0, the constant terms are going to be left over, so you can just say, oh, well, y is going to be equal to 2 over negative 4, and you do have to reduce the fraction. 2 divided by 4 is 1/2, I guess. So negative 0.5 or negative 1/2. As a coordinate, that would be 0, comma, negative 1/2. That means that this function should cross the y-axis down here at negative 1/2, just below the x-axis. Simple as that. Example 3 from your guided notes. Again, I'm going to go back to the original one. If I plug in zeros for x, the only thing that's left over is the constants. So my y-intercept is going to be found by dividing negative 15 by negative 4. Now, negative divided by negative is positive, and I'm going to turn this into a fraction. So how many times does 4 go into 15? 4, 8, 12. It goes 3 times with a remainder of 3. So 3 and 3/4. So up 1, 2, 3, and then 3/4 of the way between 3 and 4, about right there. We're going to see that function dip down in here, I'm sure, and cross right there at 0, comma 3 and 3/4. So I hope by now you're saying, oh wow, this is super easy. I can do this. I just take the constant terms because x is 0. Anything like 5 times 0 minus 5 is just negative 5. And 0 plus 2 is just 2. And then you do have to reduce this to a decimal or fraction. I'm just going to leave it a fraction. Negative 5 over 2. It's going to reduce to, let's see, 5 divided by 2 is 2 and 1/2. So negative 2.5. So let's see, on the y-axis, I'm going to go down 1, 2, and then halfway. So about right there. We can see that curve is probably going to come up through here. Awesome. 0, comma, negative 2.5. It's my y-intercept. Number 5, same thing, 10 divided by negative 4 to find that y-intercept. Lots of examples here, but I'm doing the same thing over and over again, aren't I? Let's see, that's going to be negative 10 divided by 4 is 2, and that's going to leave 2 over. You can use your calculator for this, by the way. That's going to be negative 2.5. Yeah. So you can use your calculator for this. I'm not going to show you how to do it, but your calculator reduces fractions and can change things from mixed numbers to improper fractions if you have trouble with it. You can also just divide the two numbers and get the decimal. Like this would be negative 2.5. That's okay. You can put negative 2.5 as your y-intercept. Let's see, down negative 1, 2.5. About right there, right? There's nothing wrong with that. I'm just leaving them as fractions today, but I don't have any problem with you using decimals. We know where it crosses the y-axis. We are good to go. All right, last example from the guided notes. We've got 2 over 3. 2 over 3 is what y is going to be equal to. That's just 2/3, right? So 0 comma 2/3. So 0 comma 2/3 is about 2/3 of the way between 0 and 1 on the y-axis. Done. Super easy, right? I did do some extra examples, so we'll fill those in as well. Remember, if x is 0, all that stuff goes away. We just got 2 over -6. 2 divided by -6 is going to reduce to -1/3. So on the y-axis, down a third, kind of lines up with the things that I've already got coming through here anyway, so that's great. 0 comma -1/3. And finally, in extra example number 2, remember we're going to go back here and say -15 divided by -5 is +3. And you can also look at the linear function that we ended up with and realize that the y-intercept is +3 there as well. So we already have that graphed here at +3. We already knew it was going to cross there, but just showing you that you can find it from the original function as well very quickly, 0 comma 3. So let's see. Yes, we had one more slant asymptote example to look at. If I go back to the original function, it should cross at y equals -5 over -3, which would be +5/3, right? And +5/3 is the same thing as 1 2/3. So on the y-axis, up 1 2/3 the way you can see it crosses right there. We're good to go. Very quick, very easy way to find these y-intercepts. I hope you don't have any trouble with it, but of course, if you do have trouble with it, see me in class or send me a message and we'll work on it.